All right, happy Tuesday, September 12th. I am not here. This is an asynchronous assignment. I will be going over chemical properties of matter and chemical changes in matter. Also, I will be going over the assignment W4, assignment 1, in the end of this video. So the target, what do I need to know? I can explain what chemical changes and give examples. I can identify evidence of chemical change. I can explain what is meant by chemical reaction, products, reactants, and chemical formula. Why am I learning this? Chemical reactions help us understand the property of matter. By studying the way a sample interacts with other matter, we can learn its chemical properties. These properties can be used to identify an unknown specimen or predict how different types of matter might react with each other. So we're going to look at the live lesson. Tomorrow we'll do a pair deck so that as a review. So a chemical property, the chemical property is something that describes the ability of a substance to react with other materials and form new substances. An example chemical property of sodium is that it reacts when it comes in contact with water. Reaction releases heat. So that's one indicator. Releasing heat, releasing gas, these are all examples of a chemical property. It doesn't involve appearance. It doesn't involve change in its shape. It actually forms a new material, a new substance. Example, sodium also reacts with when it comes in contact with chlorine to create salt. So sodium chloride, sodium plus chlorine gives us table salt. So sodium is a metal, chlorine is a gas, and creates salt. It's an entirely new substance with different properties of either sodium or chloride. So sodium chloride in water, it's just a dissolved. So this is just a solution of a solute and a solvent, which is a physical property. Sodium and water, you can see it reacting. It's heating up, creating some fire. It's very dangerous. That's why one of the reasons that you don't want your, like you have a lithium battery, you don't want lithium to be exposed to the air because it reacts with air. So lithium is a metal, sodium is a metal, and they both are very violent reactors. So let's classify aluminum as physical or chemical. So remember, physical is things that talk about its color. So physical, right? It boils at 2400 degrees Celsius. That is a physical property because remember, phase changes are part of physical, it's still melted or liquid aluminum, very high temperature. Density is also 2.7 grams per centimeters cubed. That is a physical property. Reacts to form a whitish coating. Whenever you see the word reacts, very ductile. That means you can make it into wire. That is physical property. Powdered aluminum catches fire. Okay. So we have physical properties and chemical properties. So you can see silver color, boils, density, very ductile, reacts with oxygen to form whitish coating, powdered, catches fire. So anytime there's heat involved, we would be talking about chemical property. So helium gas, magnesium burns in air, baking soda reacts. So you can see helium is gas. We're describing what it is. So that's a physical property. Magnesium burns in air. That's a chemical property. Baking soda reacts with vinegar, produces carbon dioxide. That's chemical. Chlorine is a yellow-green gas, or looking at the color, that's a physical property. Bicycle left outside is rusting. That's a chemical property. Rusting is changes the metal, breaks down the metal. Wooden spoons are better than metal spoons for stirring food. That's a physical property because metal spoons get hot. Kool-Aid, crystals dissolve in water. That's a physical property. And a log of cedar will float in water, and that's a physical property as well. So here's a better explanation. Helium is a gas. That's a physical property. That's a state of matter, solid, liquid, or gas. Magnesium burns easily in air, reacts with air, is combustible. Baking soda is chemical property, reacts with vinegar, reacts with acid to form a gas, new substance. So it forms a new substance. That's the difference between a state. Helium is a gas, doesn't change. It changes state, but it doesn't change into a new substance or doesn't react. Chlorine gas is blue-green or yellow-green. That's color. Bicycle left outside, it's chemical. Rusting reacts with oxygen to form a new substance. So we see again, form a new substance. Physical property of wooden spoons, conductivity of heat, less conductivity. Kool-Aid, crystals dissolve in water. Physical properties, the solubility is a physical property. Floats in water, cedar log. Density is a physical property. Sandpaper is scratchy. That's texture. It's a physical property. So now we're moving on to chemical changes. A chemical change is a change in which one or more new substances are formed. One way to tell if a new substance has been formed is to look at the new chemical properties. The atoms of one or more substances are rearranged. Reactivity versus stability. Chlorine will react with just about every element, meaning its reactivity is very high. Reactivity is the ability of a substance to go through a chemical change. The gas neon does not react with any other element, meaning it has a high stability. Stability is the ability of a substance to resist going through a chemical change. Examples of chemical changes, pick a few. All right, composition changes. A change cannot be undone, so that composition changes. Changes cannot be undone. Color changes, not always. Foaming or fizzing, smoke, heat, production of sound, light, or color. New substances formed when different properties than the original. So remember, let's just look at water, for example. Hydrogen gas is flammable, plus oxygen, which is a gas you can breathe, gives you a liquid that is important for survival, H2O. So again, totally different composition. So which of these are chemical changes? So production of gas, heat, this is rotting or fermentation, or so we get some light. Okay, so this change of state is not, and tearing paper is not. Preventing chemical changes. A light bulb gets very hot. Heating can cause chemical reactions. The metal of the filament is prevented from reacting with anything because of the vacuum inside the bulb. So there's no air inside. Heat can speed up chemical reactions. Spoiling of food is a chemical reaction. How do we slow down this process? We wonder why electronic car when we wonder why electronics come with these little packets of crystals inside. Yeah, I've seen this at Don't Eat. The packets absorb water to prevent rust on metal pieces. This prevents the new electronic from going through chemical reaction. What is the difference between physical and chemical phase changes? Okay, chemical change when a substance is formed with different properties than the original. Physical change form, but they do not make up, or they do not go through a makeup or composition. My video is unavailable. Sorry about that. Okay, chemical changes. Process involves one or more substances changing into a new substance. A new substance equals a new chemical formula, commonly referred to as a chemical reaction. New substances have different compositions and properties from the original. And it's much more difficult to reverse compared to physical change. So thinking about dissolving sugar in water, if we let water evaporate, we can very easily get the sugar back. But something like this, where we're adding some chemical to water and we get a cold or heat or light, it's very difficult to change. Get back the chemicals that we originally had. All right, so physical or chemical change, you can see if you're making bread dough and you have yeast, it rises. Okay, so that's because of a chemical reaction, and that creates a gas. Physical change, bread, if you're cutting it, hasn't changed it any. Now, if you toast it, it's a different story. Toasting it will make it a chemical change. We're adding heat to it. Okay, chemical or physical. Chemical change here, we're rusting. Oxygen in the air causes rust in the nail, and this new not only color, but it actually forms rust is a different, it's called iron oxide, and it's a different chemical formula, and it actually deteriorates the nail. You can't change iron oxide back to iron. Physical change, cutting the grass. The grass is still there, still grass. So evidence of a chemical change, a new color appears, unless of course if you just adding food coloring. Bubbles are fizzing, so like an antacid tablet, or if you're adding vinegar and baking soda, making a volcano mountain. Precipitate forms, that means when you add two liquids, you get a solid. Heat is produced, light is produced, sound is given off. When a precipitate forms in a chemical reaction between two liquids, a blank form. So a precipitate is a scientific word for something to form, and a precipitate is a solid. Precipitate is a solid. So chemical or physical. So boiling of water is a state change. So this is a physical property, but here we get fizzing. Kind of the same thing here. We got bubbling, but here we're getting fizzing and we're getting a chemical reaction. So this is a chemical change. So here's chemical and physical. So physical or chemical, folding paper, got glow sticks. Glow sticks, if you remember how they work, there's a little glass tube inside and the two chemicals react to each other. So we got, oh, this one is incorrect. This is chemical. When mixing milk and vinegar, a white chunky solid substance is formed. What has occurred? Right? We know it's a chemical change. And it doesn't say, it could be either B or D, but let's look closely. Both chemical changes, but a chunky solid is formed, so it's a precipitate. So chemical change with a precipitate. Could have been a chemical change with a new gas, but this, in this particular case, formed a solid. Okay. All right, so let's review this idea of conservation of mass. During a physical or chemical change, mass is conserved. This means that the total amount of mass does not change. This concept is explained by the law of conservation of mass. The law of conservation of mass states that mass can change form or rearranged. That's a chemical change, but it cannot be created or destroyed. So when we get 10 grams of an egg cooked, so it's a chemical change, still have another egg that's 10 grams. So the total mass is 20 on both sides. So quiz question, Trinity adds 10 grams of baking soda to 100 grams of vinegar. The mixture begins to bubble. When bubbling stops, Trinity finds that the mass of the resulting mixture is 105. So it doesn't look like it's following the law of conservation of mass, but so we might think that mass is destroyed, but that's never the case, right? And this is never the case. Mixtures always have less mass. The vinegar evaporated. Nope, it wasn't that, but it's the reason that it follows the conservation of mass is the substance reacted producing gas, right? So the gas, if we had collected the gas, we would have the same 110 grams. It's just that the gas was released into the air. Okay. So hopefully you can explain the difference with chemical change and identify a chemical change and what is meant by a chemical change. All right, so resume this, and now we're going over W4, Assignment 1, Chemical and Physical Properties. Okay, which is the answer? But choose best to describe the physical property of volume. So if we look at section on what is volume, volume is the amount of space that something takes up. Okay, the amount of space a substance has. Okay, so this is our question right here, amount of space. So I always use these side by side to help answer the questions. Choose two quantitative physical properties. So I'm going to look through the notes here. When we get to the end here, quantitative properties that do volume, mass, temperature, conductivity, magnetism. So two properties of quantitative. Got density and melting point. Okay, temperature, that's the melting point, right? And density. Physical properties describe a substance that can. All right, so let's look at physical properties. That would be the part in the beginning here. Physical property is something that describes a substance that can be observed and measured. Observed, no change in the substance. Yep, that's what that one says. And measured. Number 4, salt dissolves in water. So let's look at our examples of solubility. Solubility is the ability to dissolve in water, is an example of a physical change. Physical changes Yes, dissolving in water. You can see that the sugar has been, where it's gone. Could you taste the sugar? Can you get the sugar back? Sure you can if you let this dissolve. So it's a physical change. Which example best demonstrates the benefit of understanding physical properties? All right, I think that's the beginning slide here. Engineers can design better bridges, and scientists can easily classify mixtures. So engineers can design better bridges, scientists can classify mixtures. 6. Round ball of dough is rolled and flattened into a sheet to make a pie crust. What is the physical property of dough has changed? Its shape, right? We've basically changed the shape here. The type of changes the form but is not makeup or composition. Changes the form but does not change its composition. That's a physical change. All right, so let's take a look at a glass cup that falls off the shelf. It breaks. That's a physical change. Your homework is ripped. That's a physical change. Metal on the side of your car rusts. Now, we just talked about that. That's a chemical change. And wood is burned to create heat. And that is a chemical change. All right. So that's what I have for you, ladies and gentlemen. Thanks